This is Galen Shoup, and today I'm going to be presenting a Firewalls crash course. Later tonight, we'll have Shane presenting how to get good at defensive security. So, what is a firewall? That is technically a wall of fire, and that's also a firewall, but that's not the type of firewall we're going to be talking about tonight. Tonight, we're going to be talking about a computer security firewall. So, how do computers talk? Computers use IP addresses and ports to talk. They send data and packets back and forth across the network to different IP addresses and on different ports. So what's an IP address? An IP address, there's two different types, IPv4 and IPv6. An IP address, well, IPv4 address, which is the one we're mainly going to be talking about today, consists of 4 bytes called octets. Each one has a number 1 through 255 in it. And that's like the address of a computer on the network. And then there's also IPv6. We won't really be using that at all because it's confusing. So what's a port? A port's kind of a window into a computer, something used to send data on. There's 2 different main protocols that use ports, TCP and UDP. So UDP is connectionless and pretty fast because it doesn't have to connect, and is generally used on like a voice call when data loss is okay and speed is important. TCP, on the other hand, has a full connection. So it goes back and forth between the computer and the server to establish a connection instead of just kind of sending packets toward the server. And it also has error checking and correction, and it's generally used when all the data is important, like on a website. Though they are changing like HTML3's UDP, isn't it? So some networking terms that might be important to know. So a network is basically a group of computers that can talk to each other. A subnet is a segment of a network. Subnetting is pretty complicated, and you don't really need to know it too much. Basically, the only important thing is that slant 24 means that that last octet is going to be 1 through 254 for all the computers on that subnetwork. So subnet, basically a small network, and slant 24 is kind of the only one you need to know for the most part for now. We'll cover that later in networking. So a LAN is a local area network. That's a network over a small area, generally like a house or something like that, or even a school. A WAN is a wider area network over a large area. So that would be like, for a whole city or even the world. So what is a firewall? Firewall controls inbound and outbound traffic. It allows blocks according to a rule list, and it helps keep the bad traffic out. It's very important, and if misconfigured, it can go pretty bad. So right here, this is a screenshot of our scoring board from CCDC last year at Nationals, and we had some problems with our firewall and ended up accidentally blocking the scoring engine. So everything was down, all red. Red is bad. So there's a bunch of different types of firewalls and different attributes that a firewall can have. So stateless, stateful, host-based, network-based, layer 3 and layer 7, and then ingress and egress filtering, and of course, literal walls of fire. So stateful versus stateless. Stateless firewall does not track connections. Every packet that comes through it is filtered based on only the information in that packet, and you need 2 rules for a connection. So you need to allow the traffic in, and you need to allow the traffic out. A stateful firewall tracks connections in a state table, so you only need 1 rule to allow a connection to take place. So you can allow connected and related traffic, which means that you allow someone to call out to the server, and then because it's stateful, it remembers that when the server is responding, that's part of the connection. So you only need 1 rule. Host-based and network-based. Host-based firewalls, only on 1 host. It's like an application running on that host, so like Windows Defender Firewall, iptables, UFW, and there's a bunch of other types. And it stops network traffic going in or out of that 1 host, but only that 1 host. Doesn't apply to anyone else. A network-based firewall is a completely separate box. So it's like kind of like a router. Well, a lot of routers actually have firewalls on them. It stops traffic moving in your network. So your home router has a firewall on it, and that keeps malicious people from just sending random garbage your way. doesn't really stop you from downloading viruses, though. So some examples of that are pfSense or a Netgear or Cisco router or your home router. So layer 3 versus layer 7, that's referencing the OSI model for networking. It's a little bit complicated, and you'll get into that later. But layer 3 is basically one of the lower layers. So that's like the packets that are traveling TCP and UDP. So a layer 3 firewall can allow or block packets based on an IP, port, or service protocol. So for example, you could allow port 22 inbound or deny port 6660 UDP outbound. You can deny or allow from a certain IP, or you could just deny all traffic whatsoever. But you can't really filter based on what the actual application is talking over that. So you could just have, your SSH server listening over a different port or a web server listening over a different port. And a layer 3 firewall wouldn't really be able to block that. It would only be able to block the specific port. Layer 7 firewall can actually allow or block based on the protocol. So it can look at the traffic and be like, hey, this is web traffic, so I'm going to allow web traffic. It could only allow HTTPS over port 443, which is the default port for HTTPS. It could allow SSH outbound on any port, or it could just block all FTP traffic, something like that, and a bunch of different examples. If you wanted to have, for example, only HTTP can come in but on any port, something like that. So Ingress versus Egress. Ingress is incoming traffic, so that's connections from outside of your network to inside your network, or from outside of your computer to your computer. So ingress rules are important because you block malicious traffic coming into your network. Egress is outgoing traffic, so that's traffic originating inside your network or from your computer and going out to a different network or a different computer. So egress is important because it blocks malicious callbacks. So if bad guys do get some malware on your system and then that malware wants to go talk to its command and control network to see what it needs to do, then good egress rules can block that. And it also helps block data exfiltration. So if you have that layer 7 firewall that I talked about right here, that can actually look at the data, and depending on the type of firewall you get, it could even filter things like credit card numbers or social security numbers and prevent them from leaving your network. So both are pretty important. A lot of times people forget about egress rules, or at least in competitions they seem to. So they have really good ingress rules. Red team can't really get into your network, but then if red team finds the teeniest way around that and do end up getting something on your network, or if they had something in your network before you started throwing up good firewall rules, and you don't have any egress rules, then their thing can just call back to them, call back to their command and control center, and then they can still mess up your network and get your data. So some important terms. Allow or accept lets a connection go through. Different firewall software has different words for that. Deny or drop is silently block the connection, as opposed to reject, which sends a message back that the connection was blocked. So the difference there, like drop, if you're the computer talking to, say, a web server, or trying to talk to a web server, and there's a rule set up in between you that's going to drop the connection, then you wouldn't hear anything back. You'd just be like, hey, web server, talk to me, and the web server wouldn't respond. Reject, on the other hand, will actually send back a message that's like, hey, this port can't be reached. So there's kind of a debate about whether it's better to use reject rules or drop rules. And some people argue that it's better to reject it because that helps with debugging and definitely sends a very clear message that that port's not allowed, versus drop, where you don't know if it's a firewall blocking you, or if the server's not responding, or if there was a connection error somewhere along the line. IP tables, you can set either of them, so that's fun. And then the default policy, that's what happens if traffic doesn't match a rule. So a lot of firewalls have it set up so that there's a default policy. So if you don't have a rule that specifically says what that traffic does, it will hit your default policy and then do whatever that is. Generally, it's a good policy to have that as drop or reject, so that anything that you don't explicitly allow through your firewall on a whitelist gets blocked. So I talked briefly about IP tables. What is IP tables? IP tables is a firewall application for Linux. It's pretty common on a lot of distros. I think Debian, Ubuntu, and a bunch of other ones have it pre-installed. And so how does iptables work? It has lists called chains of rules. And each one of those well, there's 3 main chains, and then you can add custom ones, the input, output, and forward chains. So when a packet comes in, it checks that packet against the rules in whatever chain's applicable to it, top to bottom, and then the first match wins. So this is kind of a diagram of that. Ooh, pointer. It's kind of a diagram of that. So when traffic's coming in to the network or the computer or whatever, has iptables on it, then it figures out if it wants to forward or go to the input chain. So forward is if your computer's acting as a router. I'm not really going to talk much more about that today, but that's just for if it's going to send it back out and route it somewhere. The input chain is it's coming into your computer. So then it goes to the input chain. So it processes through all the rules in the input chain. First match wins. So if the first thing says, block this traffic, then it's going to get blocked. Then it goes to whatever local process. And then from whatever local process that wants to send data out, it goes to the outbound chain, and then it goes out of your computer back on the network. So, any questions so far? Yeah, okay. Looks like there's no questions. Cool. All right, so here's where it gets complicated. So, iptables. This is some of the commands that you use for iptables. So the base command right here, iptables. Then you use arguments, so things like tac I, tac A, tac D, just different things that you add in a combination to make up the rules. So this is how you insert, append, and delete rules from the chain. They have nice handy I, A, or D. It's a little bit easier to remember that. So you insert, add, or delete, append, or delete from a chain. So you pick the chain that you want to do that to. So the input chain, the output chain, the forward chain. Or if you're going a little bit more advanced, you can create your own chains to do some crazy complicated stuff. And then you fill in a bunch of options for what that rule is. So these are some of the options for those rules, and we'll come back to that in a sec. And then iptables does support stateful, being a stateful firewall. So you have to add this whole long thing to make it actually process rules statefully and regard the connections. So, and then there's a few other main arguments. So you can set the default policy for a chain to accept, drop, or reject. You can list all the rules in a chain, flush the rules, so just delete all of them. And then you can save the output to a file or restore from a file. So iptables, whenever you restart your computer, is going to delete all the rules you have as a little bit of a safety thing in case you mess something up, but also that's just how it works. So you have to manually tell it what file to restore from. So here's some example rules. So for example, if you wanted to allow port 22 TCP inbound, you'd probably have something like this. So you're appending to the input table, so adding to the end of the, or appending to the input chain. So you're adding to the end of the input chain for P, which is protocol, TCP, destination port, so where the traffic's going to is going to be port 22, and then -J accept means that you're going to just accept that traffic. Or if you wanted to say block port 3306, which is MySQL inbound, I mean, you don't really want people to be able to hit your database from outside your network. That's kind of bad. So do something like this. So you'd add to the input chain again, protocol TCP, destination port 3306 for MySQL, and drop. Or you can also allow a certain IP address. So for example, you could allow 10.0.0.1 on ETH0 to do ICMP. So there's the command for that. Protocol would be ICMP instead of TCP or UDP. ICMP is ping. It's also kind of complicated. There's some weird flags with it and different types for it. So for now, I'd say just allow ICMP because it allows people to see if you're online, and it also allows the response if a port is unreachable. So here's back to what I was saying about the stateful connections right here. So this is how you enable stateful connections. You basically add a rule to the top of each of your chains that allows related and established connections. So when someone initially sends a packet to start a connection, it would be in state new. Then it gets there, and then the server responds, and that would be in related or established, depending on what exact type of connection you're setting up and how that protocol works. So this is going to allow any traffic that's related or established, which basically makes it stateful. And I think that's about all. Are there any questions now? Maybe? Nope. Okay. No questions? No questions? Cool. Okay. Got it. Thumbs up. Yeah, so lab time. So go ahead and head on over to h5.defsec.club, and I have that pulled up. h5.defsec.club. So I set up a little environment here, so it's going to be your name, DF101, and I have a few boxes on it right here. So we have pfSense, which is acting as a router, and then we have an Ubuntu box and a Kali box. So Kali is going to be that attacker, and Ubuntu is going to be your defender on your network. And then pfSense is just the router. We're not actually going to be getting into pfSense today. That's going to be a whole nother topic. So the default login for Kali is going to be Kali for both of them. I can't spell. And the default login for DSU is going to be DSU password 1 bang, just like everything in the IA labs. Exclamation point. Shane. So when you get in, it's going to complain that you're not connected to the internet and want you to auth. That doesn't really matter. You don't need internet for this lab. So Kali already starts with the terminal up, which is kind of nice. So these two, these two boxes are on different networks, but they can talk to each other. So does this have ifconfig? No. Right here, this Kali box is, I'm blind. There we go. So the Kali box is going to be 10.0.1.20. And then your Ubuntu box is right there, 10.0.0.10. So here's the moment of truth. Let's hope I actually managed to set this up right. So from the Kali box, you should be able to SSH into Ubuntu at 10.0.0.10. Yes. With the password. So that's awkward. Okay. Oh, wait, no. I was using the wrong username. DSU, not Ubuntu. Okay, so right there, I managed to log into Defender. So from the Kali box, which is on a different network, right here. Ooh. There we go. So the Kali box is on this network called external, which is using pfSense to route to this network called internal. So the Kali box can talk to the Ubuntu box. So they could SSH in if they were red team and knew your password or something like that. They could log in, or they could like run a script to try to guess your password. So that's not good. We don't want red team to be able to access your box and log in. We can also, where's that web browser here? Ubuntu also has a web server running on it. So from here we can go load that web server. It just says hello world. Didn't really have anything to put there. So on the Ubuntu box, first of all, if you're working with iptables, you got to be root. iptables is your firewall. You wouldn't want some normal user to be able to start throwing up random firewall rules or deleting them. So got to be root. So iptables L. So right now, we can use iptable tac L. That's the list rules. And you can see that there's pretty much no rules, and the policies accept on everything. So that's why the Kali box on the other network can actually talk in. It's just accepting all the traffic that comes in. There's absolutely no rules blocking it. So first of all, something we could do is set that default to deny or drop. And we got to set that default on input. So iptables tac P, remember that's the set the policy. Whoa. Okay. iptables tac P to set policy. Can you see that all right? I should. Okay, there we go. That should be a little bit easier to see. So iptables tac P to set the policy, and we're on the input chain, we're setting the policy to drop. So right there, it doesn't give any feedback, but if we do iptables tac L again, you can see that it's changed the policy to drop on the input chain. So now from the attacker, how do you, iLab blocks all the great keyboard shortcuts. Well, all of them. So from Kali, if we try to SSH back in, then it's just going to hang, not going to actually manage to get a connection through. Or if we go onto the website here and refresh this, it's just going to keep loading, not going to actually be able to reach through because we just threw up that drop policy. So that's just going to drop all the traffic coming in. So it's also a good thing to do that on the outbound rules. So drop. Okay, so now you also can't talk out. And then let's say SSH. Let's allow SSH through. So to allow SSH through, we want to add a rule to the input chain for the protocol TCP. TCP, since SSH talks on TCP, we want the destination port, D port, to be 22, and then we just want to allow that traffic. So add to the input rule for protocol TCP, port 22, we're going to accept that. So you run that. Now, it's still not going to work because I set the output rule to also drop. If we set this output rule to accept, then right there, you see we got that login prompt. We're able to connect. Well, if I set that rule back to drop, then we're not going to get that login prompt anymore, no longer able to connect. So this is one of the other reasons it's good to have, good to set that default policy for output as well. That way it's going to stop people, even if you mess up a little bit in your firewall, that should help at least mitigate the damage from that. So we also want to allow SSH out, or SSH server to talk back to the client so that they can actually log in. Because currently we're just allowing SSH to come in from anywhere. So we also need to allow that SSH server to talk out. So if we go back to that command, then we just need to change it a little bit. We're going to add, instead of the input rule, we're going to add to the output rule. And instead of destination port, we're going to do source port. So from Kali, it picks a random source port and then sends it to the destination port 22 on the SSH server. And then when the SSH server is responding, it sends it from source port 22 to whatever that random port that Kali picked out was. That's all handled internally. And for the most part, we don't really care about what port they were using to talk to you. That's generally not too important. So if we do this, that's going to add to the output chain for protocol TCP source port 22. So from port 22, it's going to accept that. So if we list that again, you can see now we also have that rule up here on output. So then from Kali, we're going to be able to SSH in again. And we got that password prompt. But this web server still isn't loading because we haven't allowed that. So if we wanted to allow port 80. All right, so there we go. That's the rule to allow port 80. So we want to add to the input rule for protocol TCP, destination port 80. We're going to accept that. So again, now our website's still not going to load because we have that default policy on output to drop all everything. So got to go back and add to the output table or the output chain. Got to add everything from source port 80. And then, assuming I did this right, yep, there we go. We got that hello world, and we got that website to load. So right now, it's operating in stateless mode. So, stateless mode. So whenever a packet's coming in, it has to match a rule. And then when the packet's coming out, it also has to match a rule, and we have to specifically allow each one of, or each protocol, each port we want out. So if we want to enable stateless mode, well, first of all, we can delete some of these output rules. Actually, we can do iptables, tac f, output. It's going to clear the output table, or the output chain. So now you can see there's nothing there. So that's going to, once again, that's going to break. Our SSH no longer connects. So now, let's see if I can get this one right first time. iptables. So we're going to add to the output chain tac m, which is just module. It's kind of confusing, but it's like different subsystems kind of in iptables. So we want to use contract. Then CT state established and related. So that is just like right here, this command right there. So allowing from the contract module, established and related, I think, yeah. Okay, that looks like it's spelled correctly. And if I spelled that correctly, yep, there we go. So now we have that full connection on SSH. If we look at our iptables rules again, you can see this did add a rule right down here that says anything that's connection state related or established gets allowed. But because we allow SSH inbound, since they can connect in and talk to the server initially, then this means the server can send that related and established connection traffic back to the SSH client. So now this also enabled that web rule for port 80 HTTP. So we can refresh this and see didn't have to load it, or well, it loaded immediately. So now the firewall, or at least outbound, it's doing stateful rule recognition. So if the connection was allowed inbound, now it's going to allow it outbound. But say we wanted to go out to like some other server. Well, okay, that's not a good example. Say we wanted to, I don't know, ping the Kali box right there. We can't ping that. Or if we wanted to, well, yeah, if we wanted to talk back out to the Kali box, then we aren't going to be able to do that. So, what else? What other rules? Is there anything in particular? Does anyone have questions on anything? Anything someone wants to see? Let's see. I got a question here. So if you were messing with output rules, can you allow specific sockets for a custom program or whatever? So with iptables, at least, you could allow the port that socket's talking on, if that's what you're saying. Or well, with any layer 3 firewall, you're only going to be able to allow that port if it's using a TCP or UDP port. If you're using a custom protocol, that's not going to work. Is that what you were asking? I don't know, maybe, hopefully. Okay. Cool. Are there any other questions? No? So I also have, right here, I have a few examples of stateful and stateless config, for this box at least. So if we go, stateful, there we go. So right here, oh right, that's what I was missing. I completely forgot. So these rules, if we do iptables tac L, so these rules we have right here, this is just allowing SSH in and HTTP in, and then all established connections on input. So these rules, if we restart, they're just going to get lost because iptables resets your iptables every time you restart. So we can save them to a file using iptables save and then the name of the file. So test1. Oh, yikes. And you have to redirect that. So just iptables -save will output the config to just to the terminal through stdin. So if you wanted to save it to a file, you have to use that caret, which is the redirection operator. So it's going to save that output to test1. Now we have right here this file test1, and if we cat test1, there we go. Then that's the same as that iptable save command. And then we can also restore them. So if we just do iptables restore from test1, and that restored it. Now nothing really changed because that's the rules we already had. So if we do -F to clear it, so now that just deleted all three of those rules we had. And then we do restore again. Then there you can see we got all those rules back from the file. So that's kind of nice. And if we wanted to say restore every time the computer boots up, then we just have to run this command when the computer boots up. So I did that already. So if we look at the cron tab, I just threw it in cron tab because cron tab's simple and easy and works. So right here, there's a rule in cron tab. So at reboot for a cron tab means that every time the computer reboots, it'll run. It's going to run as the user root because we have to be root to edit the IP tables. Don't want unprivileged users setting our firewall rules. And then it just runs that command. And it's actually restoring the table currently on boot, which is just an empty config right now. I didn't actually put anything in that. Okay. Yeah, so if we wanted to, there we go. If we wanted to, instead of doing table restore like test1, then if I reboot, which I don't want to do because that takes a bit, then it would restore these rules we had allowing SSH and HTTP in. So what about outbound traffic? So if we wanted to go to a website, well, actually, restore. So if we wanted to go to a website, I just right there restored it from that empty rules table so that we can actually go out. So if we try to go to some website, we're actually going to be redirected to this. This is in the IA lab. In order to get internet access, you actually have to log in. So let's see. Nope. Okay, I don't know my password.
Just say it out loud and we'll help you out.
Okay, password, one bang. There we go. Okay, so I managed to do that. So I can go to some website. So if I go to like Google, then Google loads. Yay, Google works. So if I restore the rules back from test 1, which is the config we had, so that's right here where we have the SSH and HTTP in, and then related connections out, then Google's no longer going to load. You can see it's spinning there. If we go to, I don't know, Bing, then you can see that's not going to load at all because we're not allowing that traffic out. So let's say we wanted to allow outbound traffic. So we would add to the output rule. Let's do protocol TCP destination port. So we're going from our computer to the server, and the server's an HTTP server. It's a web server, so that means that it's going to be port 80. So we're going to the server's port 80 since it's hosting the web server, and we're going to allow that connection. So I capitalized the J there. And then, so we did that. And then we're also going to want to allow like port 53 UDP. Whoa, UDP. Okay, there we go. So 53 UDP is for DNS, which is how it knows that google.com goes to an IP address. That's kind of the topic for another talk, but just quickly, necessary for you to get to google.com. So we're going to allow that one out. And then, let's see. So we got 80, we got 53, and then 443, which is HTTPS. Also got to allow that out so we can actually go to google.com. So we just allowed all three of those out. And then if we refresh this, then it's still not going to work. So try to go to Google. It's not working. And that's because iptables-l. So that's because we just allowed all this stuff out. Oh, I spammed that rule kind of a lot. That's because we are not allowing the response back in. So when the server sends the response back, we're not currently allowing that back in. So in order to do that, let's just, no. There we go. So this was the command to allow those stateful connections back in. So then if we wanted to allow, or back out. So if we wanted to allow them in, then we'd add that to input. And now we can see it also added that right up there under the input chain. So now, hopefully, assuming I didn't mess anything up too bad, if we go to Google, it still doesn't work. For input though? All right, I messed something up. Let's see, what did I mess up? So we allow HTTP in, we didn't allow, yeah. I'm guessing, is it DNS? Oh yeah, I guess that's true. Oh no, it did load. It was just being slow. Ha, my rules did work. So, yeah, so now with those rules, that means that you can talk to some websites. So yeah, you can talk out to websites, and then people can talk back in. They can talk on SSH, and they can also go to your website that you're hosted here. Yeah, I think that's about all I have to cover. Oh, right, one important thing. So we're hosting a website here, so it's on this computer. So what if we try to go to, what if we, yeah, oh wait, what, why that's not supposed to be working. Oh yeah, right, never mind, we're allowing it out. I went in a circle. So, not nano, iptables stack, there we go. So let's say for a sec, we wanted to SSH locally. There we go. That's a good example. So we don't allow SSH outbound right now, but let's say that we wanted to SSH to localhost. It's kind of a problem. We can't SSH locally, which is weird. We should be able to. So the problem here is that when this box wants to talk to itself, it's actually still doing output and input traffic. It's just going straight back to itself on what's called the IPA. There we go. On what's called its loopback adapter, which is kind of complicated, but basically the computer talks to itself using network traffic. And our IP tables are currently blocking that because we're not allowing outbound SSH traffic to anywhere, including to itself. So that I had that in one of the slides right here. So this is important to do if you're blocking traffic and still want to communicate locally, or to communicate to services still on the box. You have to add using TAC-I, which is interface, and LO is the local loopback interface. So this basically allows all traffic on those loopback interfaces. So if we iptables add to the input chain, so keep capitalizing J. There we go. So right there, we run that, then we can see we have, where did that go? Right, oh, it's not even gonna show. There we go. Well, it's not showing up in the interface there, but you can see right here we have right at the top of the local, or the input chain, allowing local traffic back in. And then we'd also have to do that on output. So the output interface is local, and not there, here, output. There we go. So this is allowing all local traffic on the output interface. So now if we try to SSH into localhost, there we go. It pops up that, do you want to connect? Yeah. Any questions? Any comments, concerns? Need to go over anything? I'm good. Okay. Cool. In a few minutes, we will resume with Shane presenting how to get good at defensive security.